Well, welcome. This is our second keynote speaker. This is Cynthia Nicol from British Columbia. I first got the privilege of hearing her at a Canadian Math Society meeting and knew absolutely we wanted her to come and share her perspectives on self, community, and land, and how it affects the pedagogies of mathematics. And so I asked her, and I don't think it took that long, maybe 60 seconds for her to say yes. And so I'm very pleased to introduce her and turn it over to her for a 55-minute talk. And by the way, after this talk, as one of the sessions in parallel, we'll get a chance to informally discuss some of the issues that she raises in her talk. So you can stay tuned for that. So Cynthia, I'll turn it over to you. Thank you.
Great, thank you. Well, good to see everyone that's able to be here and attend this. And I just love the idea of a virtual conference. It certainly makes it a bit more equitable, especially for people who are on the edges and not can't necessarily have the funds to be able to attend the conference face to face. This is my first time attending this conference, so I wanted to thank you, Brian, for the invitation and the very warm welcome. My presentation will introduce ideas of place and how our connections to land shape the relationships that we have with each other and with mathematics. And I'm hoping that we can, together think about how place and math can help us as educators respond more to the pressing issues that are in the world right now, like climate change, like political unrest, and think about asking ourselves how we might learn to live differently together and the role that mathematics can play in that. So I'm a member of the Faculty of Education at the University of British Columbia in Vancouver, Canada, and it's situated on the traditional unceded lands of the Musqueam people. And this is a beautiful image of it. And just for those who would like a little different scale view, this is North America, and the red dot there is Vancouver. And this afternoon, I'm zooming in from the traditional unceded lands of the Hunkaminam speaking people right here on the Fraser River. And I know people are joining from different places across the US and internationally. I know there's a number of people from Colombia. So I just invite you to introduce yourself in the chat. If you know the lands that you're currently on, you can put that in the chat as well. If you want to learn more information about the lands that you're on, you can go to native-land.ca, and there's a beautiful map there that will allow you to get more information. I now live in Vancouver, but I grew up in Rossland, and this little yellow dot here on the map shows the place of Rossland. It's very close to the US border, but pretty kind of central in BC. And I grew up in this small town in the mountains of the Kootenay Territory, and it's near, as I said, the American border. But I should say it's not America's 51st state. Just want to put that out there. I remember my schooling here was really rarely connected to the place in the mountains and the lands of this area. We had very few opportunities to learn more about what it meant to live mathematically in this place. And so that when I traveled up to Haida Gwaii in the Pacific Northwest as a new teacher, I taught math to students mostly of Haida ancestry, but I was really keen to think more about, like Tracy Jagger says, to try to be the kind of math teacher I wish I had had when I was growing up in Rossland. So here's a map that just shows where Haida Gwaii is in the Pacific Northwest. And these lands and the waterways are just beautiful, really powerful. We have like regular storms there that were hurricane force winds. And this image here, we're looking north towards Alaska. And my students and their families taught me about the importance of relationships and reciprocal respect, and most of all, the need for humor. And my students also taught me about how math could bring us together. My connections to Haida Gwaii continue, like for the past probably about 18 years now. The Haida Gwaii School District and I have worked together with community elders and artists like Reg Davidson here to design culturally responsive approaches that draw upon Haida culture, land, and community and mathematics. And for me, culturally responsive approaches are ways of being with math and with students and their families and the communities and this land in ways that support well-being for all, where place and the land is our teacher. So we developed math lessons around stories told by Haida elders, such as Raven Brings the Light and Raven and First People. And this was a story made by a teacher who used a canvas clamshell and had all the students gather inside and try to estimate how many of us can fit inside. And then had some more mathematical problems after that. We also looked at the Haida seasonal calendar. This is written in Haida, and produced a book called Kluwai Wadlahan. It was set up with mathematical adventures that were based on Haida elders' stories and knowledge holders' stories, along with a mathematical adventure. And this is one page in that book. So there are examples of culturally responsive math teaching approaches, and they all focused on drawing upon stories that students bring with them to the classroom, and their connections and knowledge and strengths that come with knowing their communities and the families and their connection to place. And then this book came out a couple of years ago. It's exploring some of the same ideas around culturally responsive education, but this with international contributions from educators and researchers around the world, just showing examples of how people are exploring these kinds of ideas and the experiences of living educational practices that are really grounded in Indigenous perspectives and pedagogies. So that's giving you just a little bit of a background on kind of where I'm coming from with that work. But alongside this project, I have another that's kind of just wrapping up a little bit more, and it's related to displacement worldwide. And it's estimated that we have over 120 million people displaced worldwide by the end of June of 2024. So these reports are still coming in. And this displacement is due to war, conflict, and food insecurity. And it represents about 5% or 5.3 million compared to the end of 2023. Close to 40% of those displaced are children under the age of 18 years old. And my work has taken me to this refugee camp called the Dadaab refugee camp. It's the largest protracted refugee camp in the world. And you can see here that for the past 12 years, there's been a year-on-year increase from 2022, where it was about 108 million people, to 2023 with 117 million people. It's an increase of about 8%, and 8.8 million people from 2022 to 23, and already we're at 5% increase just from the mid of June. So you can see how it's becoming a really severe problem. Here, we can see like the different surges in displacement across time due to war and conflict, but it's not only due to war and conflict, but also to famine and climate change that force people from their homelands. Here's a picture that was taken just outside the Dadaab refugee camp, and they're seeking the shade of this tree, waiting to be admitted. So in response to the increased number of people that were displaced worldwide, my colleagues and I designed and offered a teacher education program in the camp. And we did this in order that higher education would still be possible while living in refuge in these kinds of conditions, because it's often that education isn't necessarily one of the pillars that gets addressed when you're in refuge. So we had an opportunity for like learning without borders. You can see here a couple of my students were exploring circle properties in the hot sun, the hot Kenyan sun. So this experience was very powerful, and it really taught me more about the need for both local and global place context for math education. And all of these examples are really thinking more about how, like on Haida Gwaii, the examples that I was bringing to my students were trying to help them think about what it meant to live and read and write the world with mathematics in the context of Haida Gwaii. But from students in the Dadaab refugee camp, they were more interested in learning about elsewhere, not so much what was in the camp, because they were, kind of imprisoned in some sense in that camp because they were unable to leave there. So they were really more interested in learning about elsewhere. So this idea, what Eric Gutstein calls reading and writing the world with mathematics, all requires us thinking about the context, the place or the community of the land. So this is all setting up my agenda for this talk. So I've done a little bit of an introduction. I'm going to talk a little bit about perspectives of place, and then I'll talk a bit about place and math education, and then excuse me, give you some examples of pedagogical examples of reading and writing the world with mathematics through data feminism, Indigenous story work, and making things, and then just conclude with some thoughts and some questions that we can go into the next session afterwards, as Brian explained. So just thinking about perspectives of place. So sometimes the terms space and place and land are used interchangeably. So let's start with space. Here, I learned to ask this question from my colleague, Laurie Rubel. She says, what are some mathematical examples that have the word space in them? So I've given you a start here with Euclidean space and projective space. So if you have a chance, you might just write in the chat, like, what are some mathematical spaces that you can think of that terms that use the word space in it that are mathematical in nature? So you can give you a second, you can just put that in the chat. Okay, we've got some responses there. So let's do the same with place. What mathematical terms can you think of that have place in them? This one's a little bit more difficult. So one way of describing the relationship between place and space is to say that place is a space that has some kind of meaning. So like this example of a university dorm on campus here, and here is a map of the dorm. So these are places where someone's trying to make some a space, trying to make it a place that has some kind of homecome to it. Here is also some examples of an imaginary place like Hogwarts Castle, and here is an example of a community garden. All different kinds of places. So here's Earth as a place, but it's viewed from space. And here's a map of places in the world, and these ones are ones that are currently in conflict. Here are some mushrooms that were in my backyard. And here's an image of Wasco, a supernatural being who lives at Spirit Lake on Haida Gwaii. The walking path of Stanley Park in Vancouver, some of you may have seen this or visited there, looking towards the mountains from my university. Those are both places. And here's the map that I mentioned earlier at native-.ca, nativeland-.ca, that shows the world from the perspective of Indigenous languages. So these are all examples of places that at a range of scales, the Earth from space, the mushrooms in my yard, so from the way out to the way in, the imagined or the real, the spiritual with the Wasco, lands that are where people have been displaced or contested. And these are all various representations of place. So Tim Cresswell, in his book, he's a human geographer, wrote a book on place, and he's talking about how place has three key attributes, building on the work of John Agnew. And he says, first of all, that place has location. So I can have my own location with longitude and latitude in Vancouver and compare that to what that might be in Toronto. And I can do that using and describing my position using the degrees of east and west along a line of longitude, or north and south along the degrees north and south along the equator. So I can describe my position. So that's one conception of place. The place also can have location for social relations. Like this is a recent poll raising on Haida Gwaii, so people are coming together in place for this social relationship. It can also be a hockey game like this one that I recently attended. And just to mention, we're looking forward to the game tonight with the US versus Canada in the Four Nation Cup. Hope people are going to watch. Here also is a community garden where people are coming together. All these places function as locations for social relationships. So a third aspect of place is also that it has meaning. So you can use it to locate. It has a place for coming together as social relations and also having meaning. So here is another residence on UBC campus and how a student has tried to make that residence home by bringing these various items, books and maps, etc. that she's put on her flags that she's put on the wall. So thinking about how we can also feel placed or displaced as this student might have felt when they first arrived at UBC. So all of these examples so far are pretty human-centric. They're all examples of how humans are creating place out of space by trying to give it meaning. But Indigenous scholars like Herman Michel and others, such as Elmer Ghostkeeper and Sandra Stiers, write about how place is more than location and more than a location for human and social relationships. Place or land is a way of knowing and experiencing and relating with each other. And it's a field of relationships to each other in the world. It includes all the languages and memories, emotions, histories, spiritualities that really root people to land. And I think Glenn Cloutard says this really well. So from an Indigenous perspective, humans are more a part of the land rather than owners of the land. And from Indigenous perspective, humans are part of place rather than creators of it. And Herman Michel writes that place is grounded in storied relationships to mountains and rivers and waterways and trees, and that land is alive and considered as a teacher. And he uses these 5 different dimensions or perspectives of place to think further about it. So living beings can impact and shape place, and place shapes and can impact living beings and the kinds of relationships formed and how they relate to each other. There's a really good video clip that actually I can put some of these in the chat after I talk. I don't think I can do 2 things at the same time here, but this one is called How Wolves Changed the River. And it's a short clip, but and you may have seen it before because millions of people have seen it, but it's a story around how the wolves in Yellowstone National Park changed the river. The last pack of wolves in Yellowstone Park was killed in around 1926. And so they were hunted nearly to extinction. Then they were reintroduced to the park in the mid-1990s. And this video shares the story of how the reintroduction of wolves had this cascading effect to change the movement and the flow of the rivers. So it's a good example of how beings can change place. And here's another example. This one is another example of living beings changing place. And you may have seen this before, but maybe not, because it's kind of an amazing case. This one is around beavers. And this is a beaver dam. It's the largest one in the world, and it's so large that you can see it from a space satellite. And I've marked it there with the little marker there. The front end is about 7 football fields long, and it holds about 92,000 dump trucks of water and 1,600 hockey rinks of water, just getting into the hockey again as examples. But here you can see how these beavers have certainly impacted and changed the place that they're living in. Another example is grizzly bears. So Tiwa scholar and ethnobiologist Greg Kaheti writes about how Indigenous people were led to their medicines by bears. And for many people in North America, bears and people have coexisted together for thousands of years. And the Navajo language, many medicinal plants have a Navajo name, the Navajo word for bear right in the name of the medicinal plant. So for example, there's a plant that treats stomach pains. And the bears seek out that particular plant in order for it to feel better. And humans have watched bears do that and have learned from bears about what kinds of plants they might be able to eat to also help them. So it isn't surprising then in this particular paper published in 2021, where a team of researchers from the University of Victoria and other institutions collaborated with 5 First Nations groups in BC's coast, and they reported in that report about how well, first of all, they took 11 years to create the data for this particular report, and they found that there are 3 genetically distinct grizzly bear groups living in these 3 areas here. I have the slide. 3 different areas. And you can see these 3 areas are shown here by blue area, a red area, and a green area. So there's 3 different types of grizzly bears, and they all map alongside 3 different language groups of Indigenous peoples in these areas as well. So the research team found that the grizzlies, just like the people, had everything they needed just in those areas. They had all the rich salmon to eat, the water, the materials for their shelter, and that there was no need to move any further. So it just shows and suggests that the land has also shaped the behaviors of the bears and the people in this particular case. And yet this is no surprise to the elders and the community members in the territories where this research occurred, because the authors even dedicated the paper to an elder who taught them that the people learned their language and way of life from the bears. So that the bears in this community were considered like a family, and the people wanted them to be kept at a respectful distance, but nonetheless they were still family. So when they were trying to decide whether or not they had enough fish for the season, they would always consider what would the bears need in order to stay a respectful distance away. So all the decisions were made in this very relational way. It wasn't so much what do we need as humans and how much can we collect, but more what do we need so that we can live in harmony and live well with humans and bears together. So a very kind of interconnected approach. So these examples are just how place shapes and impacts living beings, and how living beings can shape place. And this is just a nice model. I found that a very kind of interrelated model of thinking about place and shape, and the cultural species of the bears and humans. So you might just think about in the chat, how does land or place shape you or us? And what are maybe some other examples that you have found that you've come across about how, or even how we could draw upon our own local expertise to think about land as teacher, and how we can live and learn from land. So all examples of thinking about place and land a little bit differently. Okay, so that's leading me to the next section, which is around place and mathematics education. So this is an interesting question, because for thinking about the positives and the negatives that math and the relationship between math and place. So for better or for worse, math has shaped place, and we use math to make the world more livable. So math has helped us think about responses to the COVID virus, for example, giving us disease-resistant seeds even to increase our agricultural yield. Ways of addressing food insecurity. We can use math to find alternatives to fossil fuels, build dams on rivers, have clean energy and power. These are all examples of how math can make the world more livable. But if we go back the other way to think about how has math made the world less livable, that's sometimes a little harder to think about. So how does math or place shape math? And it might take you some time to sort of think about that idea of how math has made the world less livable, but it might also just be alongside thinking about all the fossil fuels. Being able to access fossil fuel, for example, has also created great pollution and carbon dioxide, etc. So all of that is related to not only shaping the needs of humans, but also shaping to the detriment of the planet and Earth. So let's think a little bit more about how we typically do math. It's typically taught at the elementary and secondary level of sitting in a desk, usually in rows, and usually you have a class of about 30 students and more, 50 or more sometimes in other places in the world, depending on where you are. And typically you have a pencil and a piece of paper, and sometimes that paper might have some grids on it, grid lines, but it might not. But by sitting and being in the space in this way, you have a particular view or perspective of what it means to do mathematics. So we're trying to think about how to kind of push our or rethink our mathematical, reimagine what it might be to sit and be in the world mathematically, and what would happen if we stood up or we engaged in a more kind of embodied way of thinking about mathematics. So my colleague Peter Littledahl, who you may know, has written a book called Building Thinking Classrooms. And he is a big advocate of redesigning the physical space of the classroom. So he suggests just pushing the desks out of the way and having, he calls them vertical non-permanent surfaces, or just whiteboards or blackboards all up and around the room, so students can get up and work together on problems in a way that the front of the classroom isn't as obvious. So it's kind of disrupting this idea of what are the ways and spaces in which we do mathematics. My other colleague at UBC, Dr. Susan Jarofsky, does this really well. And this is quite a nice example of her work with secondary teachers. And she published this article at the Bridges Math and Art Conference a few years ago, working with the spiral of Theodorus. So that you might remember is where you make a right angle triangle, and the hypotenuse of that triangle becomes the leg of the next one, and you just keep making them larger so that they spiral around. So we could make that with paper and cut it out and draw it, and then put it out like that. So again, we're making it on our desk, and it's smaller than we are, and we're looking at it from a particular perspective. Or, as Susan did with her students, you could make these pieces be more life size, more like the size of us, and be inside the spiral rather than looking down and on top of it. So in this way, that students are kind of taking the mathematics outside the classroom, and they're looking at it at a scaled image, from their desk to being within it, and then thinking about, how do I understand this spiral differently by walking through it and being within it, and how then thinking about how place can shape the kind of mathematical activity that we can do. And as mentioned earlier, or you saw this image earlier, but trying to think about taking mathematics outside the classroom and going out of the building and considering place in our teaching of mathematics. So you might in the chat, if you want to keep being interactive, I'm not really drawing much of the chat because I'm making my way through it, but you might think of what other kinds of placed disruptions can you think of. So going outside for a math walk, which I'll talk about in a sec, or drawing circles in the sand, or being within a spiral, being inside of a square rather than just looking on the top of it, are all good examples. Or even here, being outside in the garden, paying attention to the patterns and the variations in the garden that are experienced, rather than looking at diagrams or photos of images of plants. Robin Wall Kimmerer, in her book Braiding Sweetgrass, has a really nice example of talking about how kids, if they're given like a page of corporate logos, students, this was done with students in the US, were able to name almost all of the corporate logos given to them. But if you gave them, 50 or so set of different leaves from trees in the local forests, very few of them were able to name the species or the attributes where they were associated with the plants. So something for us to think about there, who's teaching who. If we go outside, we might pay attention to the spirals, like in this spider web or the fern, or even think, going from that small out to space, to thinking about the spirals of the galaxies, to think about spirals and fractal growth here, like in broccoli, or the fractal growth of the fern, where you have the fern inside of a fern inside of a fern, or how place shapes the connections made, like noticing the patterns here of the tributaries are also fractals. I took this photo on my way to Las Vegas in the state of Nevada, and how that is similar to the tributaries here flowing to the sea. And how that even is connected to the veins that are in our bodies, that run through our bodies. And here's a bit of a funny one. Even thinking about the hand of Doctor Strange Marvel series, where you have a hand on each of your fingers, and then on each of those hands and the fingers of those hands, another hand, and then continuing on. Kids love working on this and trying to figure out how many hands and fingers there actually are there. Or to even exploring how hummingbirds make their nests, or how place shapes the kind of mathematical structures that we might even find in the ocean, like these crocheted designs or examples of hyperbolic geometry, which we don't teach enough of, I think, in high school or even introduce in elementary school as an alternative to plain geometry or Euclidean geometry. So like kelp and kale and lichen, those are all biological representations of hyperbolic spaces. The place shapes the formation, the structures, the mathematical structures of how these grow, how these coral-like shapes grow. So changing the places of where we might engage mathematically could shape our perspective of what mathematics is and the kind of mathematics we can do together. And this is another nice example here of the hokulea, which is a Polynesian canoe used by the Polynesian wayfinders as they sailed across the islands without any technology or tools or sextants or compasses. And they had no landmarks. They sailed far enough that they had no landmarks to guide them. So instead they used these wayfinder maps, star maps they're called. This is Nainoa's Hawaiian star compass map. And this one is Maui's compass, where the east is where the stars rise and it's at the top of the circle, and west is where the star sets and it's at the bottom, and north is to the left and south to the right. So the direct, and you can notice here that the directions on the circle are not evenly spaced or even numerical, but they're named for the actual stars or the constellations that arise as they're moving forward. But what's really cool about this too is that they have a different way of thinking about what the relationship between, let's say, the canoe or the hokulea, for example, on the oceans, where the canoe is stationary and the waves are moving under the canoe while the stars move across the sky. So it's a really different way of thinking about orientation and positioning and relating to the Earth compared to that longitude and latitude description I gave earlier. Or we could go outside for a math walk. This is if you go to this Math City website, it has over 30,000 tasks that are trails from around the world. And you can upload a task wherever you are and try it out virtually. Here's one here that's near my area in Vancouver. And here on the image on the right is just a walk that you could do, where each of these various points here take you to a different math task. But math trails and the kinds of math activities highlighted here in this image here, although they might be outdoors, they don't really engage students with place and land in a way that really helps students learn more about place itself, its historical, ecological, ethical aspects of it. So like in this diagram with the leaves, I'm kind of using just the leaves as like a piece of paper, 5 + 5. It's not really helping me learn more about what it means to be mathematical in place. And Francis Su has a nice way of responding to that. He says that we're all, every culture has math explorers because strategic thinking is mathematical thinking. And he talks a lot about how mathematics can be curious and exciting and can cultivate this expectation of enchantment. And I'm really trying to work with my students to be able to think about that and how we might do that in a way that brings us closer together. So other ways that we can sort of think about that idea of how place and land shape our mathematical adventures, and to use Frances Sue's term, mathematical adventure. Jo Krona in her book, Way Indigenous Pedagogies. Jo Krona is from the Kitsun First Nation on the Pacific Northwest, kind of just across from Haida Gwaii. And she talks about how learning can support the well-being of the self. And so I've taken that to think about, how can learning mathematics ultimately support the well-being of the family and the community? How can learning mathematics ultimately support the well-being of the land? So I'm trying to pay attention to these principles that requires students thinking about becoming mathematical adventurers, but also doing this in this community of thinking about well-being of self, land, place, and family. So being a part of the world, but also thinking about being a part of this world for the better, and thinking about how to change that. And Eric Gutstein in his book talks about that. Here, I have a picture of it. He titles it Reading and Writing the World with Mathematics. And he draws upon the work of educational philosopher Paulo Freire and others like Marilyn Frankenstein to think about how can we read, like interpret the world with mathematics, and how can we write, like WRITE, write, or interpret the world to make a difference, to change it, to transform it. So thinking about that from a different perspective is Greg Kaheti, who I introduced earlier. He writes about a really holistic place for creating opportunities for students to come together culturally and in a community knowledge way, and to have as a goal to try to interpret the world with math and science in ways that really support the well-being of the self, the community and family, land and ancestors. So it's building on this work of reading and writing the world with math, but in a way that focuses more on this well-being of self, land, and family. So just kind of briefly thinking here about in the context of reading the word and the world. Paulo Freire talks about this quite nicely in terms of what it states to both like read words and read worlds. And I just want to help us think about that from a mathematical perspective. Winona LeDuc, an Anishinaabe Ojibwe activist, she talks about, what kind of ancestor do you want to be? So if we think about mathematics and self and family and community, land, ancestors, thinking about what kind of ancestor do we want to be, and how do I want to use mathematics to be able to think about the world in a different way? So this is a report that was released from the United Nations in 2023, and it talks about how the global greenhouse gases are going to be increasing and exceeding 1.5 degrees from pre-industrial levels in the near future, in the 2020s, and expected to exceed 2 degrees before 2050. And from the Canadian Commission of the Environment, the federal government is not likely to meet these targets to reduce this by 40%. And especially now with the political situation we're in, I think it looks pretty grim in terms of what we're thinking about in terms of addressing global emissions. So there's a lot of different opportunities here to think about to use mathematics to help us think about, the impact that we are having on the world. Here, this is just a map of the global emissions. You can see here that China is a pretty good contributor, as well as the US. Canada looks really very small there, but it actually, per capita, Canada does a pretty good job of emitting global emissions. We pump out about 14 tons of CO2 into the atmosphere, and that's just behind the US, cranked out 15 tons by each American. So thinking about ways to read this data, to be able to be critical about it, and then to think about, what is our role in that. So just again, thinking about the world and currently what's happening with climate change. We had major flooding here in Vancouver a couple years ago. We had a heat dome that killed almost 600 people. And how some areas are affected more than others. You can see that places that have low income shelters have more or less green space. So the heat dome itself affected people who are more marginalized than others. And then you can think about even the fires that we've had in Canada, in the north of Canada, and even just the recent fires in California, all contributing to this impact of how climate change is changing the physical experience that we have. I didn't have a chance to introduce that before it clicked, so hopefully you had a chance to listen to that. That's the sound of at Sugarloaf Mountain State Park in California from 2004 to 2015. The sounds were recorded each year at the same place and at the same time with really careful collaborated equipment. And it was just playing the sounds of the birds over that period of time. And you can see how you could hear less and less of it over the decades that occurred there. So it's a powerful illustration of the implications of and the results of climate change. So, and you're likely familiar with the reports that have come out from the IPCC, and also the responses from the UN's Sustainable Development Goals, with the intent to meet these by 2030, but I don't think we're close to getting to that. And then also just thinking about in Canada with trying to think about unlearning the colonial logics that have happened for many non-Indigenous people, where they didn't learn at all about the horrific harms made to Indigenous students while they were attending Canada's residential schools. So these are just examples of how the public is becoming more interested in human rights and trying to unlearn these colonial logics, where British Columbia just recently accepted into law the Declaration on the Rights of Indigenous Peoples that was made in 2007, but we just recently accepted it as law. We have Canada's Truth and Reconciliation and their 94 calls to action. And then we have also thinking about here how non-humans having rights. This is the Magpie River in Canada, and how the Magpie River now has legal rights of personhood. It has the legal right to flow, not to be polluted, and to be a river. And then just again, the public becoming more aware. Here was an recent article in our paper, or 2023, about a mathematician at our university who's now including climate change issues and context in his course for math exploration. I find it interesting that because it was perhaps in a math course that it was made public news. If it had happened in another course, maybe it wouldn't have been so much news. But I think it's important that as mathematicians and math educators, we need to be thinking about this for our classes and thinking about what can we do, what would be our role in trying to read and interpret and write and transform the world with mathematics for the well-being of many. So I have a number of resources here that have just with this image that are I'm sharing here. And if you know of other resources and thinking about math and social justice, or thinking about math and climate change, you could put some of that in the chat. And I wanted to share kind of quickly some examples, pedagogical approaches that can help us think about reading and writing the world with mathematics in this more holistic way. So one is through using this book called Data Feminism that lists these 7 principles of data feminism that go from examining power to trying to think about embracing pluralism, looking at rethinking binaries and making labor more visible. And you can download a copy of this book for free as a PDF, so you can begin to think about some of these. And there's other books that are available, like Kathy O'Neill's Weapons of Math Destruction. So I had my students work with those principles and create topics or research topics in this graduate class. thinking about mathematics to read and write the world. And they put their projects up on this Padlet. So I just so you can just see the kinds of projects that they're working on. So we have math and mental health, thinking about math and period poverty, looking at thinking about math and social justice. So math and polar bears, outdoor math, these are all just examples of things that we could have, projects that we could have our students work on that also help them think about these big ideas and how they might contribute to that. And then how they might get their own students be able to think about it. I'm just gonna move a little bit more quickly because I'm just noticing my time. And share with you just another couple examples. This is one is from a group of Cassie and Charlie Ray, who did a project looking at the price of food in different places in Canada. And I used the framework of the privilege hazard, where costs are different based on what kind of group you're in. If you're a marginalized group living maybe in remote communities, you're going to pay a lot more for your food than if you were in So you get the idea with that little TikTok video of the very high prices, and this was a few years ago, the very high prices of food in the far north. And then thinking about what are the contributing factors to that, the structural oppression, how can we make sense of it, and then how can I use mathematics to try to question the food subsidies that were offered, et cetera. So this is the work of the students themselves, thinking about how they can bring their own students to use mathematics to look at some of these injustices. This was another example of two students who lived in two different communities, and they had their students, these are my grad students, had their own students talk to each other and compare and go out shopping for a set number of items in their communities in Dease Lake, which it's up north in northern Canada, Surrey, which is a large city just in the lower mainland of Vancouver, and in another community of New Denver, which is again a small community in British Columbia. And so the students went out with a shopping list and looked at the prices of a set number of items in all three communities. And then they compared the price of those items and then met through Zoom to talk about why there was so much difference and whether or not that was fair.
Sorry, I don't understand.
I had another activity where students were to think about the principles of data feminism, looking at emotions and embodiment by looking at this Dear Data project. It's just an amazing project. It started with two people, one in London and one in the US, and they would take a common theme and then just use data to be able to describe that particular collection of data over that week and then visually represent it and then send their postcards to each other. So my students did this in looking at, in this case, the sounds that I hear in a day. And then this is one for Kim, and then this was Lana's. And then they just exchanged their diagrams with each other. And this was a week of moments of overwhelm, and then having a key and then just trying to keep track of it, but being able to share that with each other. Another quick example is with kindergarten, grade 1 students who noticed that the wheelchair spot was larger than the other spots in the parking lot. And they asked their kindergarten teacher, Ms. Lamba, why doesn't she get to park here? Because it's a larger spot. And wouldn't you want a larger spot? That was the view that the kids had. So they did a quick little accessibility community walk with a wagon that they pulled around the community to see whether or not they were able to visit all of their friends and how accessible their homes were. They went out and they measured the spot and tried to see how many kids could fit in the spot. They used cube link blocks to look at the measurement. They represented that in different ways. And then they wrote a note to the principal saying that the school needed a new parking spot, an accessible one, because there was more than one person in the school who could use that. There was more than one person who needed a wheelchair access. spot. And then it was like 2 years later, in 2023, where this actually came to fruition, where the school actually came and painted a new wheelchair spot right there for them, which is pretty cool. A second approach of thinking about reading and writing the world with mathematics, connections to land and place, is with Indigenous story work. And Joanne Archibald has this website, this amazing website called indigenousstorywork.com, where she goes into more detail about these 7 principles of Indigenous story work. And my students use these principles and stories by Indigenous authors to bring mathematics into the story and to help better understand the story through mathematics. So this is an example of how a teacher used these connected with students in these 3 northern communities from Vancouver up north there. And the students noticed that the time was different in the different communities, where the sun would set at a different time. And so they compared the sunsets across these various communities, and then wrote a letter to their member of the Legislative Assembly to say that this wasn't fair, that some kids are going to school in the dark or going home in the dark, and they wanted a different kind of a time set rather than having daylight savings time to keep it in the same way. And then this is another interesting project with a teacher who lives or works in a school that's surrounded by really large stumps like this, and she called it walking among the past with these very large stumps. And she used had the students go out and measure the stumps and collect data around the stumps, and be able to then to estimate, what would this have looked like before settlers came in and cut all the trees. How old are these trees to estimate them? How big will they be? How can we compare them? And so students went out and collected their data, and then wrote about what they saw, what they noticed in them, and then came back to these principles of Indigenous story work to think about the reciprocity of what happened during the colonial time, of how the land was treated, and what are the implications of that, and then what is their new responsibility. So in some ways, it kind of had this walking story of math, where you're looking at, what happened here, what are the stories that these stumps are telling us, what are we learning now, and then what do we want to happen in the future. Okay, and then just finally, and then I see it's 12:55, so I need to wrap up. But this is just a really interesting project that I want to share. They're all interesting, so that's why I'm excited to share them all. But this is a beading project with Nico Williams, and he's an Anishinaabe beader living in Montreal. And I came across his beaded hyper blanket, and that just got me so excited. So we connected, and he actually did a presentation at the Bridges and Art conference a few years ago. So he's a geometric glass beader. We started with beading triangles, and we did this all through Zoom because we started this during the pandemic. So we had 160 people sign up through Zoom. We learned how to build with Nico's teachings, learned how to build these triangles. Here I put my triangles together and made an icosahedron. We learned how to build these hyper squares, which has a saddle point in 2 different ways there. And then people wrote their little artistic stories of what the square meant to them, and what the mathematics was. So we were kind of exploring with that. And Nico would tell some stories about perseverance, and which laid along, paralleled some of the challenges that we were experiencing when we were trying to learn to bead. This was a beading done by Stan Manu. He is a mathematician and nearby at a university nearby. And at the time we were doing this, there was a large volcanic eruption in his home of Tonga. So he beaded the eruption. He asked the question, how can I bead circular rings to tell the story of this eruption? And so he did that. And then he noticed that in his beads, he could tell in his hypersquare that the beads could show the eruption as well as the wavelengths of the waves themselves as they went out. It's quite an amazing piece that he did here. these are just examples, but I want to show you what we're making now. This is my I'm calling it the Hockey Night in Canada version, because these are all the colors of various hockey teams. And people sent in their hypersquares, and now we're putting them together. We just recently were able to reconnect, and we're putting them together now in this hyper blanket. And people are using this mathematics of the hypersquare in their calculus classes, as well as in younger classes, just to talk about shape and color and form. So just to wrap up, I wanted to just talk a bit about this idea of flourishing and how thinking about mathematics as a deeply human theme, but it can be really beautiful in terms of thinking about how we can bring in the more than human and the human so that we can all flourish, land and place. And then just ending with Winona LaDuke's question again, helping us think about, what kind of ancestor do you want to be? Okay, thank you.
Wow.
I was kind of rushing at the end there, so sorry about that.
No,
but hopefully, if people are interested, we can chat about some more of that in the session afterwards.
I really want to thank Cynthia for sharing. I mean, the word passion is an understatement. Thank you very much again. The next